bring to you circle theorem. Now, circle theorem is one of the topics in high school, and some students find circle theorem to be difficult, others do not. But trust me, circle theorem is not difficult at all. So by the time I finish with you, you'll be able to appreciate circle theorem very well. But the rule here is that you have to at least practice 1 hour every day on circle theorem. Alright. So with circle theorem, I'll begin with some of the patterns or the parts of a circle so that we can really understand some of the terms, so that when we get to the solving parts, we will not be able to find it difficult. So I'll first draw a circle. Forgive me if it's not really a circle. I'm just sketching too. So I'll first draw a circle. Now the center. Now the circular portion of the circle is called the circumference. So a circle is not only about the circular part, but everything in the circle together with the circumference makes the circle. But the circular part is called the circumference. Now a circle has got a center. So in every circle theorem question, they will tell you where the center is. So don't worry. So if here is a circle, let's say O, then a line drawn from the center of the circle to touch any part of this circumference is said to be the radius. So if I draw a line from here to touch here, this is the radius. If I draw a line from here to touch here, this is the radius, because I am drawing a line from the center of the circle to touch any part of the circumference. That is the radius. So this is the radius. Now, if I draw a line such that that line divides the circle into 2 equal parts, then that line is said to be diameter. So that line passes through the center and divides the circle into 2 equal parts. Then that line is said to be a diameter. Now there is something also called chord. You hear chord in circle theorem question much. But the difference between diameter and a chord is that diameter divides the circle into 2 equal parts, but a chord is not able to divide them into 2 equal parts. So yes, a chord also divides the circle into 2 parts, but it's not able to divide the circle into 2 equal parts. So if I draw a circle, this is my center. Assuming this is my center, and then I draw a line here. In fact, this line is dividing the circle into 2 parts, but not equal parts. So this is the small part, and this is the larger part. Now the larger part is called the major segment. Major segment. And the smaller part is called the minor segment. So anytime you draw a chord, you divide the circle into 2 parts, not equal parts. For the circle to be divided into 2 equal parts, then we make use of the diameter. So that is that for a chord. So this is a chord. You can have a chord here. This is a chord because we divide the circle into 2 parts. This can be a chord. This can be a chord. This can be a chord. But for a diameter, it should pass through the center. Then again, you should be able to divide a circle into 2 equal parts, right? So we make use of chord a lot here in this topic. Now let's also consider something called arc. An arc. Now an arc can be any part of a circumference. So an arc can be here. This can be an arc. This is the circumference. So any part of the circumference said to be the arc. So you can have a major arc. You can have a minor arc. Is that okay? So a minor arc or a major arc. But any part of the circumference is said to be the arc. Now also we shall make use of this term, subtends. Subtends. Anytime you hear subtends, it means creates. So we create angles in the circle. Now you will first talk about something before. I want to illustrate how angles are formed. That is very, very crucial. I want to illustrate how angles are formed within the circle. Before we move on to the theorems. Okay, so how angles are formed. Now, supposing this is a circle, okay, supposing this is my circle, I've got a center here. See, I've got a center here. Now, before I can create any angle in the circle, I will need two lines. Before I can create any angle in the circle, I will need two lines. And these two lines probably must meet before I can form any angle in the circle. It's different from forming angles outside the circle. In forming angles outside the circles, I don't necessarily need two lines, but to form angles within the circle, I need two lines. So, assuming I have this line, and then I have that line, and these lines must meet. Anytime they meet, then I can form angles from it. So I can form an angle here. So I form an angle, and this is an angle. Now let's watch something here. You see, these two lines are meeting at this point to form angle. Now, you see that the distance from this point here to the distance of the other points, these are the two lines, and these two lines are originated from this point. So if I draw any arc from here to there, that distance we refer to that one as the arc. So this is the basis for these lines, or this is the arc in which these lines are originated from. Now, if I want to use a line, to combine them together, that line is a chord, because this chord, if you clean up everything here, this chord divides the circle into two parts. That is this part and that part. So here, anytime you hear of a chord, you can assume as an arc. What I mean is that anytime a question is being given to you and you don't see a chord, for instance, if they give this angle to you, let's say to find this angle, you don't have a chord here, you can complete the chord yourself, because the chord is proportionally same as the arc. If you stretch the arc, you will get the chord. So anytime they give a question to you and then you are being given an arc like this, you can try it and draw the chord yourself. So that is what I want to put across. Now, let's start with the theorem 1. Now, theorem 1, you will start with when you are being given a question and then you have equal chords, subtend some angles at the circumference or at the center. How do you go about it? If you have equal chords, so this theorem 1 is equal chords or arcs subtend the same angles at both the circumference and at the center. Equal chords or arcs subtend the same angles at both the circumference and at the center, of the circle. What do I mean? What I mean is that whenever you are being given a question and then they give you some angles in which all the chords or all the arcs are the same, and definitely the answer for this angle will be the same answer for this angle. So let me illustrate that for you to understand. So if I'm going by this circle, okay, so I have this arc, and this arc is subtending an angle of the circumference. Now, there is a black line and there is a red line. Now, these red lines only meet here to form an angle. These two red lines only meet here to form an angle. So over here, an angle is formed at the circumference. And now these two lines, black lines, only meet here to form angle. So an angle is created or subtended only at the circumference. So I have two angles here, angle A and then I have angle B. Now the question is, what will be the value for A? What will be the value for B? So from the theorem, they are saying that these two angles, that is angle A and angle E, if you consider angle A is originated from this arc. Angle A, this is one line, this is another line for angle A. And if you look at the distance from here to there, then this distance is said to be an arc. So this is an arc in which line angle A is originated from. Now if you consider angle B too is originated from the same arc. So meaning that they have the same arcs. Or you can say that they have the same chord, because I told you that whenever you see a chord, you can treat it as an arc. Wherever you see an arc, you can treat it as a chord. In that, when the question is given to you, you can also draw your own chord. So I can draw a chord here to illustrate that. It's the same thing. So it means that this angle A and angle B is originated from the same chord at the same time, originated from the same arc. It depends on what you want to do. But for me, for instance, I normally go with chords, because chords will make me to be able to work it out without finding it difficult, because anytime I consider them as what? The whole shape to be a triangle. So it means that angle A and angle B are originated from the same chord, the same arc. Therefore, the answer for angle A will be the same angle for answer B. So if here is 20 degrees, if this angle is 20 degrees, then definitely here is 20 degrees. That is my first theorem. Now there's another way to represent this theorem. So I'll draw another circle to do that. Good. Now, as you can see, this situation is the same as this one. I'll tell you why that situation is the same as this one. I'll tell you why. Now, when you come here, this angle B is originated from this arc, or originated from this chord. Now, when you consider this angle A, it's originated from this arc, or originated from this chord. So here they have different chords or origination. They are not originated from the same chord or arc. But this thing here is telling you that the distance from here to here and the distance from here to here is the same. So even though they are not from the same joints, they are not from the same point of origination, but they are telling you that this chord is the same as that chord. So the moment you see this thing here, it means that they are the same chords, even though they are not together here, as you can see here. They are not together. But since you have this thing here, this line, it's trying to tell you that this distance is the same as this. Therefore, this chord is the same as this chord. Therefore, the answer for A should be the same answer for B. So if here is 20 degrees, here it should be 20 degrees. Is that okay? So let's first consider an example. So one example. I'm going to give you one example. So that we work it out this thing. We work it out. Yeah. So example for theorem 1. I have a circle here. I'm not going to use red line and black line because in the exam you won't find colors. So I'm going to stick to the two black lines. So here the value here is 50 degrees and the value here is x. Now the question is find the value of x. So what will be the answer for x? Now let's see. We have angle x and we have angle 50 degrees. And angle x is originated from this chord because the lines are coming from here and here to form this angle. Now let's consider angle 50. Angle 50 is also originated from the same chord. So it means that we have equal chords that is subtending angles at the circumference. Therefore, the angles at the circumference should be the same. So if x is equal, if here is 50 degrees, therefore here is equal to 50 degrees. Why? Because equal chords subtend the same angle at the circumference. Now let me come to the second part of it. We are saying that it is not only at the circumference that equal chords subtend the same angles, but rather at the center too. So it means that it doesn't only apply to circumferences. It also applies to angles formed at the center of the circle. So if I draw another circle to illustrate that, and I have my center and I draw my diameter. Remember that diameter divides the circle into two equal parts. So I have my diameter here. Yeah. Now I have this guy here. I have this guy here. I have this guy here. I have that guy here. Now let's consider that. Anytime I make this mass, it means that this line is equal to this line. Anytime in mathematics, that is how we probably do it. So if I make here this, make here that, that means this line is not equal to this line. So the max should be the same. If it's 1 for here, it should be 1 for here. If it's 2 for here, it should be 2 for here. So this thing means that this line is equal to this line. But what is the name of this line? This line is chord, sorry. It divides the circle into two equal parts. That is this part and that part. So here we have equal chords. Even though they are not originated, as you can see here, it's similar to this one. They are not on the same joint. They are not originated from the same point. But the distance from here to here is the same as this one. So it means that this chord is the same as this chord. It applies to this one. So here, this chord here is the same as that chord. Now, the thing here is that equal chords subtend the same angle at the center. So if here is 50 degrees, then here too should be what? 50 degrees. Why? Because they are equal chords. It's the same as this one. Equal chords subtend the same angle as the circumference. Over here too, these are equal chords. So they subtend the same angle at the circumference. It also applies to this one. Equal chords subtend the same angle at the center. So not only at the circumference, but rather at the what? Center. So getting back to the theorem, equal chords or arcs subtend the same angles at both the circumference. So we can see from here and here. And at the same time, subtend the same angles at the center of the circle. So let me give you example 2. Example 2 to illustrate that. So example 2. Example 2. So if here is 30 degrees, what will be x? Therefore, and what will be y? So we've seen that we want to find x and y. So we see that these are two equal chords. And if they are equal chords, then they must create the same angle at the center of the circle. So this is the center of the circle O. So this chord here will create an angle here, which is the same as an angle here. So therefore, x is equal to 30 degrees. But what will be y? Now you see this is a straight line. Linear line. So anytime you have a straight line, when you go back to plane geometry 1, angles on a straight line makes up what? 180. So it means that if you add this, if you add this, you are going to get 180. So x plus y plus 30 degrees is equal to 180. So since x is now 30, to be 30 plus 30 plus this y is equal to 180 degrees. So 60 degrees plus y is equal to 180 degrees. Therefore, y is equal to 120 degrees. 180 minus 60 degrees, 120 degrees. Now, I must also remind you or recall that in circle theory, which is referred to as plane geometry 2, you must be able to remember some of the things we were taught in plane geometry 1. Many a time, they don't tell us, but trust me, in some of the theorems, you have to really go back to plane geometry 1 to be able to appreciate it. Now, we are done with theorem 1, so let's move on to theorem 2.